Okay, well, there you go. It seems a little far out, but the basic technology is available, and it's just a matter of will and money. Our next speaker is offering a technology which sounds impossible, but he's actually doing them right now. Maarten deWitte grows diamonds. Right? We used to think it took, I guess, a starburst, the fusion power of the sun, and a couple zillion years of evolution to create a diamond. Not so fast. Maarten can do it in 2 weeks.
Hi, everybody. Good afternoon. Happy to be here. Greetings from Silicon Valley. That's where my home base is, and it is sort of the epicenter for change in the United States, and also most recently from Las Vegas, where I just attended the largest North American jewelry show and spoke about the two concerns that the diamond industry has. Number one concern is how the heck to sell to millennials, because they're the ones that have or are going to have all the money soon. And the other one is what to do about these nasty lab-grown diamonds that have emerged in the marketplace. And those diamonds, just so you know, have been around for about 50 years. But that's a very short time horizon in the diamond business, as we'll discuss in a second. I was there representing my company, Diamond Foundry, which was launched in November last year to great critical acclaim because our leading spokesman was Leonardo DiCaprio, leading investor, and as you may well know, he had a very influential movie about the diamond business, which the diamond business was not entirely happy about. And now he's come out in favor of the environmental correctness of lab-grown diamonds. When we launched, we raised record amounts of money within a day or two from Silicon Valley entrepreneurs, which is where a lot of startup capital is. So this is frightening to the diamond business. In fact, so frightening that just last week, we were cited as one of the top 50 disruptive industries in the United States by CSNBC. So we were number 33. I can't remember who was before us, but anyway. So it's shaken up the industry, and just to the tune of which, if you would like to really get a more in-depth perspective of it, if you go to Google today and Google the word diamond, the first news item is about our company. So we're getting a lot of press and a lot of action now. By the way, my t-shirt, if you can't read it, says diamond. I am diamond. I consider myself a diamond worker. That's what I introduce myself as. My experience is as a diamond cutter. But if I were to tell you that I was a diamond cutter, unfortunately, you would think that you know what I do. And more than likely, you don't. Most people have no idea what diamond cutting really looks like. And although it's the basis of what I've done for the last 45 years, it's not the only thing I've done. It's led me to a successful career throughout the diamond industry. Diamonds have fascinated me for a long time. So a lot of you probably, you know, to me, if I say to cut, for instance, to cut means to slice. It means to wound. It means to diminish. It means to divide, take away from. That's not what I do. What I do is I add value. I make diamonds more beautiful. I draw out what I consider their inherent beauty and literally make them shine. And make them shine so that they make people happy. So I deliver to people. Now, some of you out there, I'm guessing, might not even like diamonds. There's plenty of people that do, but there are some people that say, I don't really like diamonds. And my thought on that is probably because you haven't seen one that's big enough. And in fact, that's how my journey in the diamond business began. When I was a 19-year-old hippie back in the old days, I was looking for something to do, something alternative, something that was not the norm. And I just happened to find myself staring at the Cullinan Diamond in the Crown Jewel collection in England, in Tower of London. The Cullinan started as a 3,000 carat piece of rough, size of a man's fist. It was cut into many diamonds, the biggest of which, up until very recently, was the biggest diamond ever cut, 530 carats, about that big, sets in the Queen's scepter, can detach and become a brooch. She has the second one out of that same stone in her crown, 330 carats, huge. I saw it, and it didn't glitter like diamonds that you're used to, have a little bit of colors in it like diamonds that you're used to. It sent off beams of light, all the colors of the rainbow. I saw that and I decided I wanted to sculpt diamonds. So to call me a cutter, I think would be the same as calling a sculptor just a stone cutter, or calling Geppetto just a wood carver, or calling origami just folded paper, okay? So anyway, that's my journey. That's what got me into diamonds, and diamonds have kept me motivated for 45 years. I'm not exactly sure why. Talk about it amongst my friends, but there's always something new on the horizon. What I like to do is take you on a little journey about diamonds. And that journey begins with carbon. Carbon is the most abundant, or one of the most abundant elements in the universe. Number 4 to only helium, hydrogen, and oxygen in the universe. It's in the stars, it's in our sun, it's in the atmosphere of most of our planets, it's in our water, it's in our earth. It forms in hundreds of thousands of combinations. It is ubiquitous. It is second only to oxygen in our bodies. It literally is the air that we breathe out. It's in that air. Carbon is everywhere. Yet pure carbon is relatively rare. It only comes in 3 forms. Now, I understand that Moses sort of dedicated all of this to mathematics and prime numbers and stuff like that. Am I right? I can only get up to 3. But that's a prime number. So we're going to work with 3. By the way, diamond shows itself usually in triangles, triangular faces. That's mostly what I deal with. So pure carbon comes in 3 forms. The first one is amorphous, what they call amorphous carbon. You could think of it as soot or lamp black or charcoal. It comes from combustion. And it's so soft that just touching it smudges it. Okay? That's in a lot of places. It's in the air sometimes. Very fine particulate. The other one is graphite. Graphite is extremely stable. It's actually more stable than diamond in one direction. Between layers, though, the chemical bond, is a little bit longer, so it's slippery. Graphite is slippery. It's also soft. It's so soft that it rubs off on a piece of paper. That's why we use it in pencils. Now the last one is diamond. Diamond is far more rare than the other two. And diamond is a superlative material. It's exceedingly interesting material. Let me explain it with some simple math. Diamond is made of pure carbon. Those carbon bonds, the molecule is a tetrahedra. So if you think about simple math, 1 point defines what? A point. 2 points define a line. 3 points define plane. 4 points, if one of them's off of that, a solid. So now you have this solid, and it has 4 points, tetrahedra. And every one of those directions is almost exactly the same length from one another. Cannot even theoretically think of something that's more strong than that. Now, those bonds are just far enough apart from equal length that there are differences in hardness in the direction of a diamond. Because of that, we're able to cut them, cut one diamond with another. Other than that, we wouldn't be able to cut them at all. And that hardness, by the way, on a scale of hardness that the jewelry industry or that the scientific industry has come up with, the scale of hardness, scale of 0 to 10, or 1 being talcum, 10 being diamond, the distance from 9 to 10 is a magnitude of hundreds. Okay, and 9 is sapphire, just to give you an idea of how special diamond is. Now I want you to do, let's see where I'm, a little thought trial here. I just told you what diamond is, but if you close your eyes and you imagine this matter, it could be carbon, could be any matter, and you pack that absolutely as tight as you can. Tight, 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 tight. Almost impenetrable. What color do you suppose that is? Now, those of you who are thinking black, makes sense. Those of you who are thinking white, because you're pretty clever and you're trying to keep up here, yay you. Actually, those of you thinking any color, you're good. Diamonds come in all colors of the rainbow. From opaque black to absolutely crystal clear, not even white, just clear, and every color in between. And every clarity in between. In fact, that is how they are valued. It's kind of a scale of apartheid, I think of. You know, white's best and all the other colors not so much. Unless they're fancy, you know, royalty somehow. So anyway, diamond has all kinds of attributes. It is a superlative material, hardest material we know. It's an excellent electric insulator. It is a superlative conductor of heat, transmits heat. It does things that no other substance can do. Now, how is diamond formed? 3 ways. There's that prime number again. The way that we're most familiar with is by the earth, by Mother Nature, over geologic time. Diamonds were formed by the earth, we think, 1 to 3.5 million years ago. 3.5 billion years ago, I'm sorry, over the course of geologic time. To the best of our knowledge, from now to 1 billion years ago, nothing has happened in terms of diamond formation. So the diamonds that are in the earth are the ones we've got. That's it. The way they're formed, to the best of our knowledge, under 100 miles at least, 100 miles plus beneath the surface of the Earth, tremendous heat and pressure in a molten magma that allows free carbon to rain and to attract to itself and grow crystal. It comes to the surface of the Earth through volcanic action. That volcano goes through the creation zone, brings the diamond in a other volcanic host rock to the surface, and at the surface, as it blows out the top, some of that diamond will scatter. Over geologic time, some of the volcano will wear away from wind and erosion. Those diamonds are found in what they call alluvial deposits. We'll talk about that in a second. And then you have the source rock, which is the volcanic pipe itself. So we know that that's one of the methods. We surmise what happens in the earth at that time. And then there is another method. And that method is from outer space. So we get diamonds that come in comets. And we get diamonds that come from the impact of comets on the Earth. Those are usually what they call microcrystalline, very, very tiny diamonds, not useful for gems, but nevertheless, one of the ways that we know diamonds are formed. The last way we know is lab-grown. And if I could have the picture. That is the first picture of diamonds being grown that we've ever had. That's being grown in our factory in Silicon Valley. It's a 5-7 second loop. It's just going over and over and over again. The way we grow diamonds, we start with greenhouse gas. We start with CO2 or methane. We apply solar energy to that. We cook that under low pressure. We cook that to temperatures up to 4,000 degrees plus centigrade, the temperature of the surface of the sun. What happens is and then we have inside that chamber, inside that plasma we call it, we've got free carbon and we have little slices of earth-sliced diamond. As that free carbon touches the earth diamond, it mimics that diamond. So it follows exactly the crystal lattice of that particular diamond. And it grows atom by atom, layer by layer. We know exactly the source of that diamond. We know the provenance of the diamond. We know where it comes from. We also manufacture the diamond in-house. So when we manufacture the diamond in-house, then we sell online. So a completely integrated model, hence the disruptive industry model. Now our diamond is exactly the same as any other diamond, except it can be detected not by the naked eye, not under a loupe, not by a gemologist, but only in the laboratory and only on very, very specific equipment. And that equipment is what they call photoluminescent spectroscopy. And what they can do is they can find parts per billion of trace mineral in our diamond. Parts per million is how they identify different types of diamond. For instance, our diamonds are type 2A. That means it's nitrogen-free in terms of parts per million. Parts per billion, we show some nitrogen. Those parts per billion are less than the differences between diamonds mined in Canada and diamonds mined in South Africa or Botswana or Russia. Our diamonds, we think, because of the way they're made, are eco-friendly. Eco-friendly in terms of what could be considered close to a zero carbon footprint. Greenhouse gases, solar energy, diamond. What this has all brought up in the industry, of course, is syntax problems is sales problems, is what does the future look like. I got involved in this myself because to me this is the future. The mining of diamonds today, the mining of diamonds in the past has left societies in shambles, have left holes in the earth that are visible from space. Regardless of that, we know that the model of diamond production today is ultimately a fatally flawed model because diamonds will run out. If we want the future to have diamonds, for cutters to work in the future, for consumers to be able to own diamonds in the future, there is no alternative to lab-grown diamonds. I can see that I've run out of time. I could talk longer, but I just wanted to throw out those challenges. The one challenge that I faced as a cutter when I first started cutting these diamonds was I had the same bias as most people, but they're not real. They're somehow not natural because they don't come from the earth. And then I thought, well, is man a part of nature? Is what we make from what we're given from the earth not natural? Is it not our job to make sure that we steward our resources in a responsible way? And that's when I embraced this and have embraced the path to lead into the future. So the De Beers strategy has been for years and years and years. Diamond is forever. I would add to that, it is also for the future. Thank you very much.
Minutes goes fast.
Yes. Maarten, it's so disarming. You say you throw a little methane, you throw a little CO2, you crank up the heat, boink, a diamond. Is it really as simple as that?
It is exceedingly not as simple as that. This is the ultimate of alchemy. This is what mankind has been trying to do forever, and I'm humbled. I talked about the millennials when I first started. I work for the millennials. These guys are in their 30s. They are highly educated, Stanford educated, MIT educated engineers. They're brilliant at what they do. It is not an easy process. It's not a foolproof process. It's actually a more expensive process than earth mine diamonds. I mean, the earth mine diamonds, after all, are free. So these require an extraordinary effort to make. It's an incredible product, and it's an incredible leap.
Two more quick questions. What is the productivity? How long does it take to make? How many are you making? And how do you price them relative to real diamonds?
Trade secret? No, I'm just kidding. Right now, it's taking us anywhere from 2 to 4 weeks to produce our diamonds. They are made in small batches, so small batches of 100 each. Productivity will scale up as investment scales up. In terms of pricing, that's the most difficult proposition. One of the biggest fears is that they will so-called make diamonds the price of glass. The reality is, since 1870, when they first started mining diamonds in South Africa and mass producing diamonds, over 4.5 billion carats of diamonds have been produced. About 20% of that in the last 15 years. So there is an enormous overhang of diamonds in the world. Our diamonds, the total lab-grown production in the world this year was less than 500,000 carats. So it's minuscule compared to the earth mine business. In the future, who knows what the price is. We trade very similar prices, and I don't see any reason not to. Yeah, it is diamond.
Did you bring any with you?
Don't tell Canadian Customs.
Thank you very much.
You're welcome.